Hi, I'm Gabe Ignetti. I'm filling in for Carl Pauls today. We have with us William Ikwetu, Chris Bergen, and Tim Larson. Today we're going to talk about, the title of this is Floating Bomb. The top is wind. I like that idea. I mean, wind is plenty of wind in the ocean to make a ship go faster.
Okay, so how are they going to unload that thing in a big port?
That is the bigger question.
Yeah, there's a little crane there. You know, a big ship, if it loses 15 days a year in maintenance or unloading time, it's considered a lemon.
They're always in use. And it's one thing if, like, during the pandemic, you can't even service the ships to get them in and out of port, right? But it's another thing entirely if you don't have those bottlenecks going on, that ship is expected to be constantly working.
Ship is expected to be constantly working, and I think they plan for 10 days of maintenance a year, and usually less. Any big, large ship has to be working basically 350 days, 55 days a year, or else it's considered a lemon.
So you're saying that to get the hydrogen onto the ship is going to be a big delay?
Well, no, that's mostly about energy. Here we are compressing gas, not to a liquid state. I mean, we're just compressing gas, and that's going to take a huge amount of energy. I mean, I just don't like this thing on the face of it.
My thing with this, and I was saying, and I could show you, there's horrific evidence of the failure of hydrogen in terms of safety. I mean, they had a hydrogen station explosion, I believe it was in California. I think one of the car companies just pulled out of making hydrogen cars because they were just too afraid of an explosion. It's extremely volatile. And if you're going to put enough hydrogen and you're going to condense it to cross the entire Pacific Ocean, because this is up there on the West Coast, these people.
Problems with hydrogen. First of all, it's highly corrosive. I mean, it eats metal for lunch.
Yeah, it embrittles metal over time. Yeah. It embrittles metals over time.
It embrittles metals. It leaks through solid steel.
Yeah,
I mean, after a while, it's just
the smallest. It's the smallest stable atomic nucleus, and because of and it can literally fit out in between the chemical bonds of just about every solid material.
Yeah, and after it does that, it basically lines up atom to atom and just gets pounded out of every little opening, which is the smallest opening possible. Everything about hydrogen is just a kind of a pipe dream. And
I mean, the only real place that it makes sense is in rocket applications. And look at what NASA had to do to make it work in designs ranging all the way through the space age.
Here's my be-all and end-all answer to hydrogen. Someone else, not me, figured out that we need 188 gigawatts electric just to make the fertilizer we make out of gas now. So, and that fertilizer feeds people. The Haber-Bosch process that we use to reform gas to make nitrogen fertilizer is the single greatest life-saving technological advance, period. I mean, Haber-Bosch process to make fertilizer or nitrogen, which was originally made to make bombs after World War II, has saved more human lives than anything else. And so, you know, to say that we're going to make hydrogen to move large screens TVs around the planet or to run our cars is insane. And until somebody can give me, 188 extra gigawatts of electricity to make hydrogen first, to make a fertilizer first, I'm just not interested in burning it. I'm going to eat it before I burn it.
Yeah, I mean, honestly, we already have a better option for the transportation and use of hydrogen, and that's ammonia. And we already have a huge infrastructure for doing that because ammonia is critical to fertilizers.
Yeah.
The problem with ammonia is that it is toxic in its pure state.
Yeah, but we use it for fertilizer.
Well, yeah, we're not using it as a vehicular fuel in that case.
But it's the same stuff. I mean, they use anhydrous ammonia, they inject it into the ground. So
Yeah, but what I'm saying is it's toxic to breathe, and in the event of accidents, ammonia can be problematic. But it's a much better means of transportation, of transporting and storing hydrogen than just pure compressed hydrogen is.
Yeah, I mean, there's just so much problems with compressing gas. The amount of energy used just to compress natural gas to not very high pressures is enormous.
There's also the process of turning it into hydrogen itself.
Yeah, I mean,
yeah, that. Oh, and look at the size of this ship that they're talking about. A 5,000 ton displacement vessel with a capacity of
240 TEU,
240 tons,
20-foot equivalent units. Most of the units are 40 foot.
Yeah.
So that would be.
And it's only 120 meters long. This thing isn't even remotely as close to the size of a modern supertanker. There are yachts in Bahia Mar way across the canal from me that are this big.
Yeah, this is just a tiny little ship. Where is the hydrogen being stored? Is it being stored up top? Or is it being stored down at the bottom where it's just a ballast problem? A big empty tank on a ship is not useful. Anyway, TEU is for 20-foot equivalent units. And some of those big ships are 14,000 TEU, which means they hold 7,000 40-foot containers.
I did the numbers on this, by the way. Just to run on bunker fuel would be 1/4 the price as opposed to run to hydrogen, a little more than 1/4 the price. If you're talking even about this, okay, even about this, forget about the bigger ones. If you're talking about this and you're going to Target and all these corporations and you're going to tell them, we demand that you run a profitable shipping, it's at 4 times the price on a ship that could potentially blow up.
They're going to have fueling. They're going to have special fueling in every port. This whole thing is it's just something to talk about.
And this is a study on oil fueled versus nuclear powered. And but the end result, they said nuclear powered ships of a similar specific design for nuclear republic they were comparing, and this was an article based on an article by in Forbes. What's that guy's name? I forget the
James Conca.
Yes, he had an article about this, and they were comparing 2 aircraft carriers, one that ran on a grapefruit-sized piece of nuclear fuel compared to a regular carrier, which was oil fueled, and it took 1,000 gallons just to move itself to the length of itself. And the conclusion of this study, which is, as you can see, this by Thomas Dade and Warren F. Dinzig, was that a similar sized ship, if it was nuclear, has an economic advantage over the other kind of ships. And they're not cheaper to build, but they're way faster. And they hold a lot more cargo because they don't have to fill all this hydrogen in there, or even bunker fuel for that matter. And of course, they're much more clean.
Here's the main thing. If the world went nuclear, most of the shipping industry would dry up overnight.
There you go. Exactly. I mean, we need to move energy onshore. Relying on China to build our whatever they're building for us is because they have cheap energy and they have less environmental restrictions on building stuff. For instance, the thorium waste in Baytown City. So we move all of that onshore because we have energy. And it's not going to be hydrogen energy, and it's not going to be wind energy, and it's not going to be solar, and it's not going to be hydro because we've run out of places for hydro. I mean, the only thing left is nuclear. And all of this, we're talking about one ship here.
This is what it would take just to decarbonize the electric grid. 27,500 square miles, according to Harvard Gazette. That's the size of South Carolina.
That's just false.
That's the size of South Carolina. Now that's 1/6 of the, and this is the study that shows it, that's just to decarbonize 1/6 of just our electric grid. That's 1/6. That's all we're talking about. Now, that's 1/6. Now, according to Bloomberg, and I believe this, solar needs to quadruple for US to have a carbon-free grid. In fact, we have to quadruple the grid itself. So you got that going. So if you're going with South Carolina to get those hydrogen ships going, add on Rhode Island as well. At least I'm just throwing it out. That's not an exact number. This is the Ecomodernist channel live. We're here every Saturday, 11 a.m. in the Pacific, at 2 p.m. in the Atlantic. And if you're in good old England, it's Greenwich Mean Time. I think it's 7. Thank you. Please subscribe to us on YouTube, Ecomodernist channel. Also to subscribe to us on Twitter and Facebook, Ecomodernist Society of North America.
And online at https://esna.earth.